Well, greetings, mathletes, and welcome back. Um, Today we're going to be, oh, there we go. I think I got it now. Today we're going to be talking about factoring polynomials. We're going to be reviewing this, so we're going to kind of hit all the high points and go from there. So let me get my glove on here. I wonder if they make these with sequins on them for like Michael Jackson or something. I don't know. Okay, so let's go ahead and get started. Okay, so factoring is the reverse of multiplication, right? It's unmultiplying. It's not the same as division. It's more like making a factor tree for a polynomial, really. We've made factor trees for numbers before, and this is just for a polynomial. So, looking at this, let's go ahead and let's see. Do I have the color I want? Yeah, that'll work. Let's go ahead and take a look at a multiplication problem. So let's say I have a plus b times C plus D. Oh, that is not a D. Let's try that again. Okay, so if I multiply this out, you have a number of ways to do it. You have FOIL, which most people are familiar with. One I actually like is the multiplication rectangle, where you write one factor across the top and one factor, one factor across the side. And then you use this table to do the multiplication. What goes in here is A times C, so that would be AC. Here would be BC. Down here would be AD. And over here would be BD. Right? And so these are the four terms. And basically everything just gets added together that's in the box now. You're looking for like terms. I don't have any, so it is AC plus AD plus BC plus BD, right? So that's our final answer. That's just a quick multiplication thing. Now, you'll get the same answer if you FOIL this out, but the terms might not be quite in the same order, but it'll still work. In any case, what factoring is being handed something that looks like this and figuring out that it started here. And so let's go ahead and look at that reverse process. The method we're going to start with is factoring by grouping. The main thing, the main way you tell if you're going to try grouping, there's no guarantee that it's going to work, but it's something to try, is when you see that your polynomial has four terms, because that is typically the form that something that will be grouped looks like. So let's actually just use the one we just did. We've already seen that it multiplies out to give us AC plus AD plus BC plus BD. Let's see if we can figure out where it came from. We already know the answer, so this would be a great way for us to check ourselves. So I have AC plus AD plus BC plus BD. All right, so here's the grouping method. So when you have four terms, and again, this won't always work. Some things can't be grouped, but it's a matter of just trying it and see if it works. But you want to split between the front end and the back end, right? So you have two terms up front, two terms up back. I like to leave whatever this operation is, I like to make sure that is grouped with the backside. It doesn't matter as much when it's a plus, but when it's a minus, that becomes very important. So now what we do is we look at the front end, just the front end, and we ask ourselves what the greatest common factor is here. And between AC and AD, the thing that is common is A. And so I'm going to write this A down. And then let's do this. I'll color code this. If I factor an A out of this, what it's left with, in fact, this is a good way to think about it. Think about what would need to be here for the distribution to give me AC. So A times what equals AC? Well, C. And then A times what gives me AD, so that ends up being a D. And so I finished with the front half. I factored out the greatest common factor. Now on the back half, I want to do the same thing. So between BC and BD, the common factor is B. And so I need just to see what is left. So B times C gives me BC, and B times D gives me BD. Let's try that again. I already pulled the B out. Gives me D. There we go. Okay, so now this is what our second line looks like. I have A times the quantity of C plus D plus B times the quantity of C plus D. Now the two things I'm looking at now, because we've turned the front end into one term and the back end into one term, and if we look at this, the common factor between the front end and the back end is C plus D, and so I can pull that out, and that's what I'm going to do. So let's pull out a C plus D, and you'll notice what I'm left with when I pull a C plus D out is what's in red here, A plus B. And so I have C plus D times A plus B. That is my final answer. And you notice it matches this one. It's in a different order, but it's the same factors. Okay, so let's just go ahead and walk through the grouping process one more time, just kind of review the process. So we were handed a polynomial. It had 4 terms, and we thought, aha, 4 terms, that might be a grouping problem. So I split it between the front end and the back end. And I pull the common factor out of the front. So now we're here. And then I pull the common factor out of the back. And the hope, and this is how you tell if it's actually going to work or not, is that, let me switch colors so we can see this. This piece right here will match this piece right here. If they don't match, it's not going to group. But as long as those two match, you can pull it out. And you notice what I'm left with. I have the A and the B, and that gives me this term. Right? So we factor the front and the back end, and then we find the common factor, pull that out, and then whatever's left is the other factor. Okay. So let's look at another example here. We just did this one. This part right here, this was more just illustrating where everything came from. This is not part of the factoring process. So you don't have to start with a multiplication problem. I started with that to illustrate that these two processes undo each other, basically. Okay, so let's go ahead and clear this guy off. There we go. All right, so let's look at another example of grouping. And this time, because I think a lot of you are probably familiar with the process already, just to double check yourself, once I write the problem down, pause the video and see if you can work it out on your own, and then play the video and watch the rest of my explanation of it and see if you match up. Okay, so let's look at the next problem here. So we have, oops. These problems turn out, it's easier to write them when you turn on a writing tool. There we go. At some point in this semester, I'm going to remember that little tidbit. Okay, so, yeah, so 2x cubed plus 6x minus 5x squared minus 15. Okay, so that's what we're looking at. So pause here and try the problem on your own. Okay. Now, when approaching this problem, I know as soon as I see 4 terms, I'm thinking it's probably grouping. That's probably going to be the easiest way to get started. The other thing you should be looking for, look across all 4 terms for some common factor, because sometimes you can factor that out and it makes all your numbers smaller and it actually makes your life a lot easier. But we don't have one of those. So we're going to go ahead and split between the front and the back. And then I'm going to ask myself, what's the common factor in the front? And looking at this, between 2 and 6, 2 is common, right? 2 goes into both of these. So that means there's going to be a 2 in here. But I also have x's in both terms. I can get up to 3 out of this term, but I can only get 1 x out of this term. So that means the common factor is just x. And a little tip, when you have several terms like this and you're trying to factor out the variable, the common factor is always in the term that has the lowest exponent on the variable. So in this case, this one's a 1. So between x cubed and x to the first is the common factor. Okay, so we have 2x here, and let's see what we have left. So 2x times what gives me 2x cubed? Let's see, that would be x squared, because I got to get that exponent up to a 3. And then 2x times 3 will give me 6x. Okay, so I got that. X squared plus 3. Now, the back end. Now, here's something different than the previous example, is we have that negative there, right? And I had mentioned that it really helps if you divide this so that the negative is with this term. So this is why it's important. If this term is negative, what you're going to be pulling out of these two terms is the negative of the common factor. So looking at this, between 5 and 15, I know the common factor is 5. I have x squared and no variable here, so there's no variable part of the common factor. But because this front number is negative right here, I'm going to pull out a negative 5 instead of a positive 5. Right? So these two signs always match. They're always going to match, just the signs. Sometimes the numbers match too, but the signs will always match. All right, so if I pull a negative 5 out of this, let's see, negative 5 times what gives me negative 5x squared? Well, x squared. And then negative 5 times what gives me negative 15? Well, negative times a positive gives me a negative. And so now we're at this step. And if I look, what's in the parentheses here matches. And so we're winners there. I can pull out that term, or that factor. So x squared plus 3 is one factor. And then what's left in red here is my other factor, 2x minus 5. And if you really wanted to check, you could always multiply this out just to double check your answer and make sure you have the right thing. You could FOIL it out. You could do it. I'm going to do one more this way, just in case you haven't seen this before. You'll see one more example of it. So let's see, I have x squared plus 3, and then 2x minus 5. Let's see if we get all the same terms back. So I get 2x times x squared, that gives me 2x cubed. 2x times 3 is 6x. Negative 5 times x squared is negative 5x squared. Negative 5 times 3 is negative 15, and then I'll just write down all the terms. So I got 2x cubed plus 6x minus 5x squared minus 15, and that matches. So that means we factored correctly. Now, there is, as we go through these techniques, and really in the last few examples I'm going to do for this lecture, there's often a combination of techniques, and things like this, that x squared, could be a little flag that there's more factoring to do. In this case, there's not, because of the fact that if you guys are familiar with factoring patterns, you have the sum of squares, difference of squares, things like that. The closest you can get to this is the sum of squares, and the sum of squares doesn't factor anyways. So this is actually a prime factor. So we are done with this thing here. Okay, so let's go ahead and get this off of here, and we'll take a look at the next technique. Okay, now this next set of examples is going to be using grouping to factor trinomials, which is going to feel very unusual because trinomials, right, it's right there in the name. Trinomial, you see the the nomial refers to how many, the terms. Tri is how many. So this is basically saying it has 3 terms. And we just talked about the fact that if we're going to use grouping, we have 4 terms. So for trinomials, and in general, the trinomials we're looking at are going to be of the form ax squared plus bx plus c, right? Now, I know this is the form that you see in the quadratic formula, but unless there is an equal 0 on the other side of this, you have to have this piece to use the quadratic formula. Otherwise, you're stuck with factoring. We're not going to be given this piece. So there's going to be no equal 0 on these right now. In any case, let's go ahead and take a look at one of these and see what to do with it, because it does feel a little bit weird. Let's see here. What do I have? Let's do 3x squared minus 2x minus 5. Let's suppose we're going to factor this thing. Okay, so the trick is to turn it into a 4-term polynomial. And so there's going to be a way, we're going to figure out a way to break up this middle term into 2 different terms. Now, looking at it, if you're just going to break it up willy-nilly, probably your instinct would be to make it negative x and negative x. But there's an infinite number of ways you can break that up. I could break that up as negative 102 and 100. Right? If I add those 2 numbers together, I get negative 2 still. So there's a lot of choices out there, and we have to figure out which one's going to give us the correct answer. So here's what we do. We're going to use something called the master product. Okay, the master product is the first coefficient times the last coefficient. So sometimes this is called the AC method because the first term is called A and the last term is called C. So A times C is AC. So if you've learned it that way and you remember that and you're awesome at it, there's no reason to change up here. It doesn't hurt to see another way to do it though either. So this is the way I typically organize it. Most methods that involve the master product at any level, the big difference between them is just how it's organized, not the method itself. So I like to organize things using an X. It just visually, it's a little more pleasing to me. The master product gets written in the top, the top area of this. So A times C is 3 times negative 5. You have to honor the signs. This is going to be negative 15. That's my master product. Then at the bottom, we put a sum. Okay, and the sum we want is whatever the middle term is. So the sum I have here is negative 2. Now, again, this is just a way of organizing so that you can find the information a little bit quicker. So what we're looking for here in these 2 spots are 2 numbers who multiply together to give me negative 15 and add together to give me negative 2. Okay, so there's some choices here, right? I could have negative 1 and positive 15, or I can have 1 and negative 15. But when I add those together, they don't add up to they don't add up to negative 2, right? Negative 1 plus 15 is 14. 1 plus negative 15 is negative 14. So I'll look at my 3 and 5. So let's look at negative 3 times 5 and 3 times negative 5. Actually, I should write that this way too. Well, okay, so that they both give me a product of negative 15, but when I add them, negative 3 plus 5 is negative 2. Oh, that's my winner. Yeah, and no, that's positive 2. Oops. Okay, and then 3 plus negative 5 is negative 2. So this one's actually my winner. So I write down my 3 and my negative 5. Okay, so the 3 and the negative 5, and this is how we check it. 3 times negative 5 is negative 15. 3 plus negative 5 is negative 2. Now, there are some things you can do to narrow this down. If the product is negative 15, you know that you have to have one positive and one negative factor. Otherwise, they won't multiply to give you a negative number, right? If they're both positive, you get a positive. If they're both negative, you get a positive. So if that product is negative, these guys are opposite signs. Now, if this sum is negative, that means of the 2 factors here, the bigger one has to be negative. Otherwise, they won't add up to give you a negative number. So hopefully some of those little tips will help you kind of iron out what's going on here. Okay, so these are the numbers that we needed to find. This is how we use them. What we're going to do is we're going to break up this middle term into 3x minus 5x. Right? You notice that if I collect those two like terms together, I get negative 2x still. So I haven't changed the value of the problem. And then I'll bring everything else down here. And that's a positive term. And that would be minus 5. And you notice now we have 4 terms in our polynomial. That means we can use grouping. So once we have the 4 terms, we're just going to do grouping like we just did. So the common factor in the front, let's see, I have a 3, and then there's an x in both terms. So that would leave me with, let's see here, 3x times x gives me 3x squared, and 3x times 1 gives me 3x. That's something that people miss a lot, is writing down that 1. It's got to be there. Because if you don't put it there, all you're going to get back is 3x times x and get the x squared, not the 3x. Okay, now in the back half here, common factor is negative 5. And that leaves me, let's see, negative 5 times x gives me negative 5x, and negative 5 times 1 gives me negative 5. Okay, so from here, I can see I have a common factor of x plus 1, so I'm going to pull it out. And that leaves me with 3x minus 5. Okay, so that was a much longer process than what we had to do in the previous one. So let's go ahead and walk through the whole thing again. Perhaps it'll be a little bit quicker now that we've worked out all the little details. Okay, so we were presented with this polynomial. And so we realized that we weren't going to be able to use grouping on it because it was only 3 terms. So we found the master product and we organized stuff over here, right? Master product on top, middle term sum, the sum on the bottom. And we figured out the 2 numbers whose product is negative 15 and whose sum is negative 2. Those 2 numbers are then used to produce these 2 terms. Once those 2 terms are produced, we can break the front end from the back end and follow our normal grouping process to the answer, right? And that gives us our answer here. Okay, so here's what I want to do. What am I looking for here? I want to give you guys a chance to try this on your own. So let's go ahead and give you another problem to work on. So let's try 6x squared minus 7x plus 1. So what I want you to do is pause the video here, see if you can factor this, and then once you're finished, go ahead and push play and go ahead and watch my solution. Okay. Now, so let's go ahead and walk through this process. So I see 3 terms, so I'm immediately going to go for my magic x here. My master product is 6 times 1, which is 6. And the sum I want is negative 7. In fact, that looks too much like I accidentally put a negative there. Okay, so I want a product of 6 and a sum of 7. Well, here's some things we can figure out. The product is positive, which means it's either a positive times a positive or a negative times a negative. The fact that the sum is negative means that both of my numbers here that I'm adding together are going to have to be negative. So really all I need to do is find 2 numbers that multiply to give me 6 and add to give me 7. And if we start pushing things around a little bit, I know 2 times 3 is 6, but 2 plus 3 is 5, so that's not right. And then there's 1 and 6. 1 times 6 is 6. 1 plus 6 is 7. And if I just switch the signs, which I already have, oops. There we go. Right, which I already have written in up top. I can see that they add up to negative 7. So it's going to be negative 1 and 6. So now that we found our magic numbers, that's how we're splitting our middle term. So our middle term now will be minus x minus 6x. So I'm splitting up the negative 7 into two terms. Then the rest of it I'll just bring down. 6x squared and plus 1. So now we should be able to group this. So I'm going to split this between the front end and the back end. My common factor in the front, let's see, 6, well, I got nothing to common factor that with. So it looks like x is going to be the only thing that I have as a common factor in the front. So that will leave me with 6x minus 1. Now the back end here, well, let's see, I have a negative, so I know whatever I'm going to pull out is going to be negative, right? And that's because of this guy. And if I look across this, let's see, 6x and 1, normally you would say there is no common factor, but what that actually means is the only common factor is 1. And so in this case, we still have to pull out the 1 so we can see what's going on. So if I pull out that 1, or the negative 1 really, negative 1 times 6x gives me negative 6x, and negative 1 times negative 1 will give me positive 1. So now I can see that this matches with this, so that means I can pull out 6x minus 1, and I can put down x minus 1, right? And this ends up being our final answer. A common question I get is, does it matter which order you write the factors in? And it does not. You could just as easily write x minus 1 times 6x minus 1, and that is absolutely 100% correct. There's no law about what order things have to go in. So both of these are absolutely correct as far as that goes. All right, so let's go ahead and clear this off now. And before we conclude this video, I want to go ahead and look at just one example of one of the reasons that we're learning to factor. Because right now I wanted to review the factoring, but let's take a look at what the point of this whole thing is. So really what the point of factoring is to be able to solve equations. It's not the only point. There's lots of ways that factoring gets used, but this is one of the main ways. And it's particularly to solve quadratic equations. There's always the quadratic formula, but quite often, if it factors, factoring is way quicker. So let's go ahead and take a look at a polynomial and a polynomial equation, and we'll just factor it so we can see what we're actually doing here. So let's say I have 2x squared minus 5x plus 3. Okay, and that's equal to 0. Now there's no way to solve for x in any of these problems unless there is an equal sign. Because if you have something that doesn't have the equal sign, it's not an equation, and so there is no solution. It's an expression, so you can either evaluate it or simplify it, and that's about it. So what we need to do here is rewrite this so that it is two things multiplied, because here's the property we're using. If I have two things multiplied together and that product is 0, then either the first factor is equal to 0 or the second factor is equal to 0, right? Well, in this case, our factors are going to be in parentheses and have two terms. So let's go ahead and take a look here. So let's see, if I factor this, my master product is going to be 6 and the sum is negative 5. And so that means that I have negative 2 and negative 3 as my magic numbers. I'm going to switch colors here. That one. There we go. So negative 2 and negative 3 are my magic numbers. Wow, there we go. Negative 2 there. Now it looks like a negative 2. So that's how we're splitting up the 5. So now our polynomial looks like 2x squared minus 2x minus 3x plus 3 equals 0. And we split it. 2x is my common factor in the front. That leaves me with an x minus 1. And then over here, that's negative. So I have negative 3 as my common factor, and that leaves me with an x minus 1. So that's equal to 0. So now I have x minus 1 times 2x minus 3 equals 0. Well, you can actually think of this first term as your a and this second term as your b. So I'm just going to set each one of these things equal to 0 now. If I go this direction, I get x minus 1 equals 0. If I go this direction, I get 2x minus 3 equals 0. And technically, that's an OR statement. If either of those things are true, then the whole thing is 0. Here, if I solve this by adding the 1 over, I get x is equal to 1. And over here, if I add 3 and divide by 2, I get x is equal to 3/2. And those are my two answers. There's actually two of them, 1 and 3/2. So the goal is to get things into this form right here when you're factoring. If you're solving an equation by factoring, you want the factored form equal to 0. If it's equal to any other number, you can't break it up into two equations. It has to be a 0 on one side or else it won't work. So in any case, that's kind of the point. And I just wanted to review that real quick. Since we're doing factoring, it really does help to know why we're doing factoring. And this is one of the areas it's going to get used. All right. So I'm going to conclude the first half of this video here. We actually have some special cases in the second video, some special products, what to do if you only have a binomial, which means it's two terms, and then a shortcut to the whole master product and grouping thing. There's a special case in there where if certain conditions are true, you can save yourself a lot of time. So we'll take a look at that in the next video. And until then, I will see you guys later.